Hi, I'm Brandon Graisley. I teach high school computer science, and I've given my students in my grade 12 computer science class a task. They have to write an array-based data structure that stores ints and has a linear index, and they have a bunch of methods that they can call on it that does all the hard work of moving stuff around and adding to and removing from the array, instead of having to do those things manually and shuffle things around when you want to use an array. So this is an array style data structure with some additional methods added on top, and we're going to flesh this out as we move along throughout the course. But one of the things in the course that we have to learn to do is sort things in an array or search through it and so on. So having all of these additional methods is going to help make those tasks a lot easier. So let me just explain very briefly. Over here in the navigator, this is in NetBeans, you can see the list of all of the different methods that we need to implement. Some of them were implemented already, others I've implemented since. I'm going to show you each of those. You'll see this one here, double capacity, is a private method. You can see the little padlock there, because that's not something a user is going to call. That's something that the implementer of this class may need to call if something like, let's say, inserting an element would require additional storage space. The user of a LinearIntStore object is not going to call that directly, so it's private. And a few other things are private, like these values here. We've got a static final int value here, initial capacity, and I chose the number 8. That's going to be the beginning size of any array that's inside of the LinearIntStore. The array itself is pointed to by this variable here, data, and we store the number of elements that are being stored in this variable num elements. So let me go through here really quickly. LinearIntStore is the constructor, so whenever a new LinearIntStore is being made, this is the method that gets called. We set num elements to 0 and we make a new int array with the initial capacity, which I have set to 8. So that is always going to be true. And let's just move on down here. I'm going to just line this up. The first method that I'm going to implement here is called insert element at, and all this is the Java doc. If you press / and press enter before a method, all of this will get filled in. The parameter, these things are listed here for you, and you just need to type in this stuff here, a description of the method, a description of each parameter, and if there's a return value, there'll be another line for that as well. Now if I go over here to insert element at and cursor over it, up will pop a little window that is a little kind of like a little web page that shows that method's Java doc formatted nicely, and you can see the parameters are listed at the bottom there. Now this one throws an array index out of bounds exception. Anything that has an index as a parameter should throw an array index out of bounds exception. And I did forget that on one method. It might have been this one, but I can't remember which one it was. So that should be added in there. And the first thing we do inside that method is check to see whether the index is valid, if it's below 0, or if it is greater than the number of elements. Let's say there are 5 elements, then the place to insert an element can't be beyond the number 5, because 5 would be one position beyond the index that we, the number of elements that we have. So if there are 5 elements, the indices go from 0 to 4, and so you could insert at spot 5, but not at spot 6. If that happens, throw an array index out of bounds exception, and that's going to end the method. As soon as that happens, we go to this throw bit right here. It throws it back to whoever called this method, and we're done. The rest of this code doesn't execute. And you can actually try that. For example, if I try to make a new int value, I'll get a little message over here, unreachable statement. That's because that line will never execute after that exception here is thrown. Okay, let's continue through the inserting the element. Look at the comments here. Increase the size if necessary, shuffle the values down from the index, and then insert the new value at the index. Those are the 3 things that are going to happen. When do we need to increase the size? Well, if the length of the array is equal to the number of elements we already have in it, that means it's full. We need to increase its capacity. We do that by calling the double capacity method. That's the private method I mentioned earlier, and we're going to write that in a minute. So let's assume that has been successfully completed, which we are relying upon this other method for. We're going to shuffle the values down from the index. To do this, we're going to start at the end, number of elements, and actually one beyond it. If there were 5 elements, that would be positions 0 through 4. We're going to start at position 5, and we're going to copy into position, say 5, the value before it. So that's going to take position 4's value and copy it into position 5. And so on, position 3 into 4, position 2 into 3, and so on until we get down to index, the number that I want to get to, because once I've copied index, the index value up 1, then I will replace it with the new value. So this shuffles everything along, opens up a spot for me at index, and then I just have to make sure that I increase the number of elements that I'm storing that value by 1. If I was storing 5 elements, now I'm storing 6 elements. So that's all we do for that one. Get size is very simple. Just return the number of elements. Now this value here is a private value that I'm storing. I don't want anybody messing with that, and so that's why this method is available here. It's called an accessor or an accessor. It lets us get the size, but it doesn't let somebody have full access to this variable. I don't want some other programmer being able to change this number on me. I want to maintain it programmatically myself. So that's why we have an accessor or an accessor. And some people call these getters. You have getters and setters. So this is a getter. Okay, here's that private method I mentioned earlier, and it is a void method, which means it does not return a value. You can see there's no @params in the Java doc that's right here. It doesn't even take a parameter. So it doesn't take a parameter, it doesn't have a return value. All it does is it's sort of like a procedure. It goes through and it does something, but it doesn't tell you anything. It goes through and makes a new array that is twice as big as the old one. That's right here. It's called new data. Then we go one by one, copy all of the values from one array from the old array into the new array, and then we reassign the old pointer to point to the new array. Now this process right here, you're going to get a little error message, not an error but a warning. There's a manual array copy. Java includes some methods for copying arrays that are really tidy, and you can just call a method to do this instead of making your own for loop. In this course and for now, we are practicing learning these algorithms, so you need to use these for loop or something like it to make this copy happen. Okay, let's go to the next method, remove element at. We're about halfway, and I've got about 15 minutes total time, so we'll see how we do fitting this all in. Removing an element at a particular position, again we throw that index out of bounds exception if I'm trying to remove something that isn't already there, if the index value is less than 0, or in this case if the index value is greater than num elements minus 1. So if the number of elements was 5, the largest number I can allow for in an index is 4, one less than the number of elements, because our arrays are indexed from 0. Okay, so that's checking that it's valid. Assuming we get past all this, let's get the element that we want to remove and keep a copy of it in an int called result, because I do want to return it at the end. Then I'm going to copy all of the values down into that gap. So we're going to start at the gap that I've made at index. We're going to go up one at a time until we get to num elements minus 1. We're going to copy into the current spot, so starting at index, the spot that's one past it, say index plus 1. And that'll backfill everything all the way down, shuffling all the values down in the array, filling in that gap at index. We have to reduce the number of elements. Num elements minus minus, that means the same thing as num elements equals num elements minus 1. That's the decrement operator. And then at the very end I return the result, just in case the program that was asking me to remove the value wants to use that value as well. So this is sort of a get at the same time as it is a deletion. Get element at, this is asking for a particular element at spot index. Again, we check for validity, so we're pretty familiar with that now. And there's just one line, return the value that is at that spot. It doesn't change the array at all. It leaves data alone. It just grabs that number and sends it back to the calling program. Inserting a value at the end of the structure. This one you might just think to write a bunch of code for it, but it really just means you're going to insert a new value at the end. So we are going to call our existing method where we've already done all the hard work and just say please add this value to the spot that's at the end. Again, if there were 5 elements, we want to put a new value in position 5 because 0 through 4 are filled. That's why num elements is the number that we pick there. And when this is all done, that earlier method, which is insert element at right here, will have already increased the num elements value, so it will change automatically as we go through because it is a field and is stored as part of the class itself, as part of the object. Okay, we're doing good. We're at the 10-minute mark here. The clear method, which empties the structure of all values, again is void, so it's more like a procedure. It doesn't return anything, has no parameters, and all we do, instead of actually deleting anything, we just say there aren't any things in the array anymore. We set the number of elements to 0. It's got lots of room in it, but we don't care that anything is in there. Now if you needed to, you could set up a for loop to go through and reset every value, maybe set them all equal to 0 throughout the data array, but it's not necessary. Another option would be to make a new data array. I'm just going to scroll here the way we did at the beginning here. Make a new data array, and what will happen is once you remove reference to the old one, Java will clean it up and get rid of it for you. One other option that we could have done is if we had used this strategy for the clear method, we could have in this constructor simply called the clear method, since it's doing the same thing, instead of writing the same code out twice. Okay, and we are, okay, there's the clear method, so we're finished that, just one line of code. Change the number of elements. Now let's look at this one here. It's really fascinating. This is the toString method. It is overriding an existing method. Every object comes with a toString method. By default, an object will sort of give you a memory address back if you try to print it out, if you try to turn it into a string. But what we want to do instead is print out a list of comma separated values like this one that's right here. And so basically what we do is go through and get the data value and then stick a comma, data value, stick a comma, data value, stick a comma. All of this if and elsing that's in here is the difference between having a first element and then a second element where we put a comma first and then the element number. So the first time through, if I is 0, we don't have a comma beforehand. I do put the empty string though to turn this data value from an int into a string, and then afterwards we put a comma and then a data value so that it's all separated. At the end, so that's building up a return string. At the end we return that string. Okay, how we doing? 2 minutes left. We'll see how we do. These next two methods are related. Let's look for a particular value and return the index at which it was found, the smallest index. Getting an index of a particular value starting at the beginning is the same as calling the same method getIndex of value starting at 0. So here, this version of the method, which has one parameter, we don't indicate a starting position, we just have the starting position of 0 as a default or understood starting position. Instead of writing a method here, we just call the other method which implements this same thing. Here it is right here, getting an index, looking for a particular value. Here's the starting index. Could throw an out of bounds exception because that starting index could be bad, like -17 or way beyond the end of the array. We check and see if it's okay. Then we go through and we look for the value. If we ever find it, we return the index. If we don't find it, we return -1. Okay, last one. Compress. This is a method that takes the data structure and gets rid of any excess space. So we're storing our data in an array. Perhaps as I'm a user of the data structure, I might say, hey, you know what, I've finished adding stuff to this data structure. I'm only going to be removing things now, so I might as well compress it and save any extra space that I can. Maybe it's really large, like millions of entries. And so, maybe not millions, thousands of entries. What we do is we look and see if the data array is already full. It has its length is the number of elements. Then we don't need to change anything. It's already compressed, and we return 0, meaning we did not save anything. Otherwise, we make a new array that's smaller, copy all the values into it one at a time, reassign our data pointer, and then see how much did we save, the old capacity minus the new length, and we return that value. Okay, whew, that's it, just under 15 minutes. So that is all of the code for Linear Install, and I hope that has been helpful. And if you're in my class, please ask me some questions. Thanks.